Hello, hello, hello. You should be able to hear me now. Hello. If you'd like to say hello or type in the chat, that would be amazing. Just let me know that you can. Oh, there we go. I can hear some people. Fantastic. Good afternoon, good evening, good night, good morning, depending where you are in the world. Hello, hello. Good to see you. Right, so let's just get everyone in the room okay. Make sure everyone's set up okay. We've got a number of people joining us tonight, and I've just realised you can't see me, so I'll turn my camera on. There we go. Fantastic. Well, welcome everybody. It's great to see you all. Just going to set this up so it's ready to go. So hide self view. Hide. There we go. Fantastic. Right, got a few more people joining now. There we go. Right, let's just move that out of the way. Hello, Michaela, good to see you. Thanks for coming along. Just get everybody in there. There we go. That's it. I don't want to inadvertently show anything, my emails or anything on the screen. So just bear with me a second. There we go. That's good. Everyone's got the link. That's good. Right then. So I think we've got pretty much everybody here today so far, so that's good. What I'll do is I'm going to quickly do a little bit of housekeeping just to make sure everybody's sort of switched on and set up and everything. So if you can, I would really appreciate it if you were to turn your camera on so that we can see your, attractive faces, handsome faces, because then it makes the whole experience better for everybody, really. And it also means that I can use my special Fandangle technology, which allows me to show everyone all at once, so we can all, get involved, raise the energy, and have a good time. When you want to say something, or you want to ask a question, or you want to add some contribution, if you're not really familiar with Zoom, just click the button at the bottom that says reactions, raise your hand, and what that does is it notifies me that you want to say something, and I could just press one button and bring you up on screen, and then we can talk and hear what you've got to contribute. And also, of course, if you want to rename yourself, there is a button at the bottom, participants, where you can rename yourself. If your name is maybe not your name, something like that, you can add something. I think everyone's names is pretty okay, so there's no dodgy names so far. That's good. And then, of course, if you want to chat, you can chat amongst yourselves in the chat box and add some contributions. And if you already know how to do that, fantastic. Otherwise, it's just click the chat button at the bottom, type in there. You can have arguments with each other, give me some abuse, whatever it is, I'm open to it. And of course, what else? If you want to use the reactions, if there's something that I say, something interesting, particular to you, you're welcome to use the emojis, and everyone else can see that as well. It generally makes it more fun. Fantastic. Okay, so where should we go from here? So generally, the way that I run these sessions, if you've watched any of my other videos, it's quite relaxed. It's not sort of a formal lecture or anything like that. It's really about talking about STAMP, STPA and CAST. And then, of course, in this case, it's about submarines. So if you are experienced with submarines, either from an operations or a technical perspective, then please jump in and correct me, because I'm bound to say things that are incorrect. And there will be gaps in the control structure model that I've developed. As I say, if you've already watched the other 3 live streams, then you'll know where we're coming from with this case study, and you'll probably already have some ideas about how we could improve the control structure model and the type of things that we can find from it. But as I say, don't be shy, stick your hand up and we'll get you on screen. Right, let's just have another check, make sure we've got everybody in there. So we've got Andy North, good to see you, Andy, thanks for coming along. We've got, of course, we've got Michaela, great to see you. Michaela is joining us from Rome tonight, so thank you for coming along. I know it's a bit late in your Friday evening. We've got Chris. I don't know where Chris is. If you'd like to type in the chat, you're quite welcome. We've got Darren. We've got Mark. Hi, Mark. Great to see you. Thank you for coming along. And then we've got Thomas Murray, all the way from the United States. So great to see you, Thomas. Thanks for coming along. Now, before we get stuck in, are there any sort of questions anybody's got Are there any concerns? Are there any things that you'd like to sort of air before we get stuck in? If you want to type in the chat or stick your hand up and I'll bring you on and we can talk about it. Great, okay, well what I'll do is I'll just quickly practice with my green screen and my fantastic technology, so just bear with me a second. So there we go, there we go, green screen, look at that, amazing. Okay, so this is, well, it's primarily today we're going to talk about STAMP, STPA and CAS through the context of the HMS Astute submarine accident that occurred off the Isle of Skye in 22nd of October 2010. So 15 years ago now. I suddenly feel very old, as I'm sure everyone else does on this call. But I will also be talking about 3, perhaps 4 other submarine accidents, which are not exactly the same as this, but there is some commonality in the control structure model, and some of these other incidents, there are a few hallmarks which suggest that perhaps there's a common theme going on here. Maybe not just one theme, but a couple of different things that perhaps if they're not addressed, then we might see a repeat of something like this and not be so fortunate. So this, there we go. So this is the official investigation report. So that is the picture of the HMS Astute. And you'll notice that it looks quite high out of the water. And that's because it is, grounded. And then, of course, this is the picture of it when it was getting ready to be launched for the first time. So this is a Barrow-in-Furness in the northwest of England. And these big buildings behind, that's where they build these impressive machines. Now, if you don't know too much about submarines, they are incredibly complicated, complex. They are like some of the most complex systems known to man. And if you can imagine that you've basically got a nuclear power plant, some really complex weapon systems, all wrapped up in a tube that's going to go under the water. So if you think that space is complicated or complex, this is just a whole new ball game over and above that. But I suppose that the sort of one of the saving graces, I suppose you could say, compared to space systems, is that once the thing is launched, at least there is some possibility of bringing it back to the factory or to the dock so that some repairs and modifications can be done. Whereas with space systems, once you've launched them, that's it. It's a one shot. So you've really got to approach things in a systematic way. And then, of course, there's an even better of the thing in the water. Now, this is an attack submarine, so it's not a ballistic missile submarine. It's not a bomber. These do various sneaky-beaky missions that I don't know enough about to even talk about, and even if I did, I couldn't say anything. But they do some really interesting things, and of course, they are very advanced. As I mentioned, I'm really sort of hitting on the point. These things are mega complex, and so I'm sure you can imagine that behind that, the organisation that designs and develops and builds these things is also very, very complex. And then, of course, you've got the operator, the Ministry of Defence and the Royal Navy, and then their organisations and their systems for training and selecting people to do these kind of challenging, difficult missions. This is like the pinnacle of complexity. And then again, this is another sort of picture, an overview of the accident location. So this was in northwest Scotland, just south of the Butech British Underwater Test and Evaluation Centre range, which, funnily enough, one of my claims to fame is I was actually the safety engineer for the Butech range for a period of time back in 2021 time period. So I've spent some time up at the range, and it's a very, very beautiful part of the world, and the weather is very, very changeable. It changes from minute to minute, but it is a very beautiful part of the world. And of course, it's also next to the Isle of Skye, which is also a particularly beautiful place. So if you get the chance to go up there, I highly recommend it. And so this picture here, you'll notice, if I just zoom in a little bit, you'll see the submarine there. It's a bit lower in the water now, and I think this was just before or just as they were pulling the boat free, and you can see the tow lines there moving across to this vessel here, the Anglian Prince. So that's sort of where we are in terms of this. Right, what else are there any questions before I sort of continue and say anything else anymore? I'll just check the chat actually. There we go. Somebody's saying something in the chat. There we go. So Thomas is saying something. My internet bandwidth isn't good enough to use my camera. Thus, I'm leaving my camera off. No worries. Thanks, Thomas. Thanks for letting me know. Right. Are there any other questions in there? No, there's not. Fantastic. Right, let's just set that up there so we don't forget. There we go. Fantastic. Right, so before we start talking about the report and go to the control structure model, I'm just going to give you a quick, whistle-stop tour description of what STAMP, STPA and CAST is all about. In fact, actually, can we have let me just stick this effects on the screen. Could we have a show of hands on a scale of 0 to 10? So just in the chat, type 0 to 10. How familiar are you with STAMP? So System, Theoretic, Accident, Model and Processes. If you just want to type in the chat, that'll come up. So we've got some 10s. We've got 10s, 6s, 1. Andy's 1. Come on, Andy, you've seen some of these videos before. Okay, that's fair enough. Fantastic. We've got a 5 from Thomas. Hi, Thomas. Okay, great. And in terms of STPA hazard analysis, on a scale of 1 to 10, tell me again, 0, you don't know anything, 10, you could teach an engineering course on it. What do you know by, how familiar are you with STPA? So Michaela's got a 10, fantastic. Michaela, thank you. Mark got a 8, brilliant. Thomas, 5, brilliant. Darren, 6, fantastic. Okay. And then in terms of CAST, so 1 to 10 again, how familiar are you with causal analysis using STAMP or systems theory, depending on which, literature you look at. So we've got a few, got a 5, got a 10, fantastic, Michaela. Great, there we go. Got another person joining us, great to see you, thank you for coming along. That's good, okay, so what I'll do is I'll just give a quick, a quick whistle-stop tour of what we're talking about then. So the first thing to sort of highlight about what STAMP, System, Theoretic, Accident, Model and Process is all about is one of the core concepts of safety, which is the definition of a hazard. Now you might be familiar with the UK Defence Standard 0056 Part 1 Issue 7. If that doesn't mean anything to you, that's fine, just bear with us. And essentially that defines a hazard as the potential to cause harm, e.g. a physical situation or state of the system, often following from some initiating event that may lead to an accident. So that definition is quite broad, and it's about both the potential to cause harm, but also that it may lead to an accident. So you might have the existence of a harm, but you might have the existence of a hazard, but it may or may not lead to an accident. And then in Defence Standard 0056 Part 1 Issue 8, so the later version, so I think this was October 2023 when this one came out, a hazard is defined as an item, event, activity or situation with the potential to cause injury, ill health or death, damage to or loss of equipment or property, or damage to the environment. And that essentially refers to an intermediate state where is the potential for harm to exist. So again, it's talking very much about the potential for harm, and about an item, an event, activity or situation. So it's quite a broad definition, a broad set of things. Then we've got the US Department of Defense MIL Standard 882E Change 1, which is broadly the equivalent, has the broad equivalent function of MOD Def Stand 0056, but in the American context. So they define a hazard as a real or potential condition that could lead to an unplanned event or series of events, i.e. a mishap, resulting in death, injury, occupational illness, damage to or loss of equipment or property, or damage to the environment. So again, it's quite a sort of broad concept, but also it's important to recognise that this one is open to the possibility of having damage, destruction or injury or death, given that we're talking about defence systems and in the middle of a conflict, in the middle of a situation where defence offence is required, then of course that definition allows for the potential for loss or death or serious injury. And then finally, in this section, I'm just going to talk about the Civil Aerospace Recommended Practice, ARP 4761. Now, this is the safety process for doing safety in civil air transport for large aircraft, what would be called CS or FAR-25 large aircraft. And it's also used and kind of bastardized a little bit for helicopters and smaller aircraft, so CS-23 and CS-27 and 29 for helicopters. Now this one is quite interesting because this one focuses very specifically on a condition resulting from failures, external events, errors, or a combination thereof where safety is potentially affected. So again, it's about potentially affected, not it is affected. And it's also focusing on failures. Now, one of the things to understand from a stamp analysis perspective is that it looks at both failures and what I call dangerous successes. So this is where the system or the operation has behaved as designed, and that has resulted in an unwanted, an accident or loss. And so stamp includes considering failures and failure modes, but it goes on to consider dangerous successes, which is unique to stamp. And so when people say, well, what is one of the benefits of using stamp? The first one and most valuable one, arguably, is that it goes beyond just thinking about failures and managing failures. And unfortunately for analysis methods like fault tree analysis and failure modes and effects analysis, they are focused primarily on failures and failure modes. So by definition, they can't think of the opposite to failures, which are successes, dangerous successes. I hope that sort of makes sense. I'm just enforcing the point that this is the way we do it today in defence and civil aerospace. And what I'm hopefully highlighting to you and makes sense, that this is not enough. This is either too weak and too loose, and it's not a really helpful definition. It means that we're not focusing on the right things, or we're not focused enough, or it's focusing on failures and not also dangerous successes. And that's where the definition of hazard used in stamp comes in. So there is sort of, the definition itself originates from Professor Nancy Levenson's second book, Engineering a Safer World, and it's reinforced in the STPA handbook, chapter 2. And essentially it defines a hazard, and you'll notice I've used square brackets. And whenever I'm writing on social media or in reports, I always take care to use square brackets to make it absolutely explicit to everybody reading those simple words on a page that we are talking about the definition used in the stamp literature, not the standard definitions that we're all used to. And of course, if you're talking to engineers across different industries that have their own different definition of hazards, and if you talk about healthcare particularly, they don't really think about things in terms of hazards. They think about things in terms of risks and issues. And there's a whole conversation there about risk management I don't want to get into right now. But having this sort of universal definition really helps to make sure that you're focusing on the right things. And so this defines a hazard as a system state or set of conditions that, together with a particular set of worst case environmental conditions, will lead to an accident or loss. So if you think about things through the lens of a bow tie analysis, I'm going to be a bit blasphemous for a minute. When you think about things through the lens of a bow tie, you have the hazard, which is the centre of the knot of the bow tie. And then going off to the right, you'll have the effects or consequences. And then you'll have a spectrum of loss. Either nothing happens, everybody's safe but has brown trousers, all the way to complete disaster, the end of the world. And so when we're thinking about the definition of a hazard through the lens of stamp, that knot, if you like, is much, much closer to the consequences. And of course, when we're defining the consequences, this is one of the things that we do as part of the stamp-based analysis. We define those losses that we're interested in. And I'll do that now. I'll give you a quick overview of the process. So there are currently arguably four stamp-based analysis processes, which are sort of formally sanctioned by MIT. There are other extensions that are written about in various various papers and various publications, but I'm just focusing on the four that MIT sanction. There is STPA hazard analysis, which is a hazard identification and analysis process. Then there is CAST accident analysis, which is used for event, incident or accident analysis. There is also STPA SEC, which is a cybersecurity development of STPA. It is broadly the same, but instead of just looking at safety outcomes, it also looks at security outcomes. And it's important to understand that when you're doing a safety analysis, quite often we assume that the people involved, they come to work to do a good job and not kill themselves or other people. But when you're doing a security analysis or a cybersecurity analysis, you've got to get into the mind of an adversary and how they're actually trying to cause these negative outcomes. So it is a different mindset, a supplementary mindset to STPA, and it has a few other steps in it which I'm not going to show today. And then there is also STPA, Systems Theoretic Early Concept Analysis. Now that method is primarily a way of building the control structure model and developing systems and defining requirements from first principles. So it's not really an analysis method, it's more of a safety guided design method. But again, we don't need to talk about that today. Now, in the context of STPA, with all of the stamp-based analysis, I generally teach it differently to how it's presented in the literature and how it's taught at MIT. So I use a standard basic of, there's 3 parts to any stamp-based analysis. There is what I call the foundation phase, which is where we essentially prepare to do the analysis. We set the scene, gather resources, do a plan, and then execute that plan. Then there is the modelling phase, so this is where we create the control structure model or models, depending on how complex our system is and how expansive our safety assessment process wants to be applied to. And then the analysis phase, which is, in the context of STPA, that's what differs to CAST. So STPA has 2 parts to the analysis. The first part is called the control action analysis. So this is where we explore the control structure, look at the controllers in that structure, identify the control actions that move between those controllers and their respective control processes, and then we examine those to find out which ones might present or contribute to a hazard or loss. And they are defined as unsafe control actions. And then we set requirements for those. So one of the benefits of stamp-based analysis is you can actually start with very limited information, create a control structure model, and then start analysing and identifying these unsafe control actions very, very quickly. So if you want some safety constraints, especially for software and other types of complex controllers, you can identify those very, very quickly. Excuse me. And then, of course, we've got the second part of the analysis, which is the loss scenario or control loop analysis, should I say. And that sometimes you might see in the literature that is referred to as causal scenario analysis or loss scenario analysis. They're essentially the same thing. They're just different. They're referred to differently in different ages of the various literature that you'll see. Because of course, STAMP was sort of first talked about in 2004 in Nancy Levison's first sort of paper or sort of formal paper on it. And of course, over time, the language has evolved slightly as more and more people have got involved and people have practiced more and identified challenges with using language. So loss scenario or causal scenario, it's the same thing. And of course, when you do that work, that splits into 4 parts. So you'll be looking at the controller's behavior, issues with the controller, issues with how the control actions find their way to the control process, issues with the feedback path, and also with the control process itself. So there is always the possibility that a control process might behave as though it has received a control action when it actually hasn't. And of course, that's something that we might want to consider, we want to be concerned about. So that, in a nutshell, is what STPA is all about. And then in the terms of CAST analysis, again, it's broadly the same foundation phase, the modelling phase, and where the most difference is in the analysis phase. So CAST has broadly 3 parts, and they're not sequential parts. It's not like a step-by-step process. If you're doing a big investigation, you're going to have an investigation team, and different people in that team will be working on these different parts. But this is broadly how it fits together. So we have the physical process analysis. So this is where, the actual physical, in this case, we've got a submarine. Were there any physical issues with the submarine, with the propulsion system or the steering control systems or with the navigation systems, communication systems, things like that? Yes, there was. That's where we look at this. And then when we do the controller analysis part, the second part, this is where we start to look at the controllers in the control structure and identify identify issues with those controllers and their control actions. And then finally, there's the control structure analysis. So this is where we look at the broader aspects of the control structure itself. And, if we're talking about communications, for example, and we've got issues with the communications system, then of course that's going to potentially undermine the control structure and how control actions and feedback is passed between the various layers in the control structure. So that's sort of, in a nutshell, that's what STPA is and that's what CAST is. STPA is typically used as part of the design and development phase of a complex system, or if you're going to do a change project, maybe an upgrade in service, you'll use STPA. If you're investigating an incident or an accident, you'll use CAST. Bearing in mind that STPA is designed to find, and I'm going to be maybe a bit blasphemous, but all possible causes of accidents, whereas CAST is specifically aiming at the specific causes of this accident that you've experienced. Now, it is possible that you could use CAST, identify the causes of this accident, but as part of that exploration, you might find hints at or causes of other accidents that didn't occur on this occasion. And at that point, you might elect to go and have a go at using STPA based on the control structure that you created as part of your investigation. So are there any questions or comments or concerns or compliments about that? Oh, we've got chat window. There we go. I should have the chat window open, shouldn't I? So they've got loads of people chatting. Right, hang on. Sorry about that. Let's have a look. So Thomas says, failure, external threats, errors or combinations are the focus, not just failures. Absolutely, fantastic. Would it help people if I talked a little bit more about control actions and what that means and how control actions are specified? Would that help? Do you want to just give me a thumbs up in the chat? Or yeah, we've got a thumb up from Darren. There we go. We've got a thumb up from Andy. Thanks, Andy. Good to see you. So this is the absolute basics of what STAMP is all about. And I'm hoping by the end of today's session and all the videos and things that I post on social media, I hope you get this embedded in your brain as one of your mental models. So essentially, this is a very basic control loop. And if you're into engineering and you've done engineering, anything like that, this should be very, very, familiar to you. So essentially what we have is a control process. And this could be a physical process like the movement of a submarine at sea, or it could be an organisation. So if you're a leader in your organisation, your teams below you doing the various things that they're doing, that could be your control process. And then, of course, we've got the concept of a controller. And this controller, they provide control actions to their control process. So if you're driving your submarine, you're the commanding officer, you'll be providing control actions, whether that's verbal or whether it's direct interaction with some kind of control system, some human-machine interface. And you will provide control actions to that process. And then hopefully that process responds in a way that you expect. And you should get some feedback from that process. And that feedback should update your beliefs or your mental model about the control process and the control actions you've just provided. And of course, that will influence your decision making. So, you can make decisions about whether what you've just done has actually had the effect you wanted, and perhaps you want to change your actions, your decisions later on based on those beliefs. Now, in the literature, you'll probably see these referred to as control algorithms and mental models or process models. And the reason I've included decision making and beliefs is because that's the new language used in the latest literature, but it also makes sense to people who are maybe not involved in engineering directly. And of course, this has been born in the system safety engineering domain, and to help it be more accessible to people that are not in that domain, it makes sense to use these less technical terms. But essentially, this model, this jigsaw piece, I like to call it, this is one of the core concepts of STAMP. And if you can master this and get this into your head, you'll be able to identify more causes of accidents and potential safety constraints more quickly than you would otherwise do with other safety analysis methods. So Michaela says, Simon, that's a great introduction to STAMP and the toolkit. One question we often get is how to determine the appropriate level of granularity or abstraction for a safety control structure. Do you have any advice for that? Personally, I find it a challenging question to answer. Yes, Michaela, thank you. Great question. So what I always recommend is, depending upon the thing that you're working on, always think about things from the physical real world perspective to start with. What is the physical situation or process that is under control, where energy is transferred, where people can get harmed and things can get damaged, and then abstract from that perspective. Think about it through the lens of who or what is in direct control of that physical process, and then who or what is in control of that direct controller. And think about it through the lens of, you'll have that physical process, you'll probably have some layer of technology of some description, unless it's direct manipulation by human beings. And then above that, you'll have some layer of management or leadership or oversight, which will help to make decisions and decide on priorities for control actions and things like that. Now, of course, if you're involved in the development of complex software, you don't really have a physical world to sort of play with. So there's a bit of a challenge there between how much information do you have available to you as a team. If you're, I don't want to go picking any exotic examples, but if you're involved in an autonomous driving system software, for example, you might be able to ascertain that, if your steering control software doesn't control the steering properly, it might be obvious and self-evident that it, will result in an accident, and it's related to the physical movement of a car. So it's entirely obvious. But there are some organisations, and I'm not going to name specifics, but there are some organisations where those software engineers might have literally no idea what the physical process is that their system is related to, especially if we're talking about database or data systems or AI. They might be used as decision support for a particular person in a position of control, but they don't know what the process is they're actually controlling. And I'm sure you can think of some examples that would hurt people in terms of military or decision makings about deploying weapons, for example. Start conceptually with the physical process if you know what that is or you've got a good idea, and then abstract from that perspective. And then think about your perspective, your organisation's perspective in relation to that control structure. So if you're in a design organisation, you're not in the operational control structure, but you do have interactions with it and you might require feedback from it. So have a think about the design control structure and the operations control structure. Now, of course, you don't necessarily need to model the design control structure, because you're trying to create a system to put into service which will be used in operations. So think about the operations control structure. But if it is important to you and your organisation, say if you're a safety manager overseeing a development project, you might want to have certain control actions and feedback about the conduct of that project. And then, of course, it's success in the real world. So you might require control actions and feedback that are separate to the product, service, or system that you're creating. So there was a lot of words there. I hope that sort of gives you some food for thought. We can discuss it and explore it more if that would help. We've got some nods and some thumbs up. Fantastic. Okay, so that as I say, this is the what I call the jigsaw piece. And so when we're talking about control structures, what we're trying to do is identify what are these jigsaw pieces in that structure and how do they fit together. Because fundamentally, this is what we're trying to do. We're trying to look for these loops and see whether they're closed or not. Because if they're not closed loop control, that can present some unique challenges that I'm sure you might be aware of. Okay, so let's talk about another core concept, which is the concept of control actions. Now, essentially, control actions and whether they're unsafe or not is primarily about this interaction here. So the controller provides some form of control action to the control process, and if that control action is not provided, does that result in a hazard or a loss? If it is provided, does it result in a hazard or a loss? And then these other scenarios, so timing, early, late, duration, short, long, or sequence, if there's a sequence of control actions that are provided in the wrong order, does that lead to a hazard or a loss? So fundamentally, there are two types of unsafe control actions, not provided or provided. And then these timing, duration, and sequence are like specific cases of the provided control actions. And then, of course, you'll notice there I've put their magnitude in grey. Magnitude is not mentioned in the official literature, but depending on what type of control loop you're exploring, magnitude might be a relevant control action. So just keep that at the back of your mind. Now, the other part of a control action which is really important and isn't, in my opinion, emphasized in the literature enough, is when we're thinking about how do we define these control actions formally. We have this sort of standard framework here at the top. So we have a unique identifier. So you want to, you might have many of these control actions and you need to keep track of them. So they need to have a unique identity. You'll then specify, well, what is the source controller that this control action originates from? The control action type, so is it not provided, provided, or is it time in duration and sequence? And then what is the specific control action? So if it's like provide brake command, for example, in your autonomous driving system, and then the context, what is the specific context that makes this control action unsafe, and which hazard does it relate to? So for example, if you're driving down the motorway and you lose the brake command, you can't press the brakes for whatever reason, is that strictly a hazard? Is that going to lead to a loss or an accident? Well, probably not if it's a closed motorway and it's not very busy and there's not many people around. It only becomes unsafe when there's a context in which you need to use the brakes. So if someone steps out in the road in front of you, or there's an HGV that's crossed 3 lanes, for example, that context is what makes it unsafe. And so when you're trying to identify these unsafe control actions, it's really important to think about not just the type of unsafe control action, whether it's loss or provided, time in duration or sequence, but also the specific context. Because that context can, for one controller, that context might be safe. But for another controller in the control structure, that very same context could actually be very dangerous. So it's important to think about those contexts. And those contexts apply not just for this particular controller, but potentially across a group of controllers or the entire control structure. So we have to be mindful of those. Thomas, he says, so the Tesla braking in a fast lane with no cause, brakes worked, but the control action occurred at the wrong time, out of sequence. Here's where context, absolutely. We could take that control system apart pretty well with STPA, and so I'm not sure how long Tesla self-driving cars are going to be on the roads and how much money is going to be involved in various legal battles, but STPA could really open up that. Tesla could really benefit from STPA. So if you know anyone at Tesla needs a hand, then please let's have a conversation. So thanks, Thomas. Okay, so when we're analysing these unsafe control actions, one of the ways to do that, and this is sort of the standard way to do it, there are more advanced ways to do it, but I'm not going to talk about those today because it gets a bit crazy. But you essentially have a table, you list the various control actions down the left-hand side, and then you systematically explore each of the scenarios for each of the contexts. So if this particular control action is not provided, does that, with a particular context, does that lead to a loss or a hazard? If it does, then by definition that is an unsafe control action, and we need to set a safety constraint for that and put that into the design and make sure it gets fulfilled. If the control action is provided with a particular context, is that going to lead to a loss or a hazard? If yes, that's an unsafe control action. And the same for timing and sequence, and then duration, long or short. Now this sort of framework allows you systematically to walk through any control loop that you identify and highlight unsafe control actions very, very quickly. And when you combine this mental model in your head with these scenarios, you're going to be seeing unsafe control actions all over the place. You're going to become like a Neo in the Matrix. You're going to see the green code of safety in the background. Now, just to sort of highlight that for a minute, because you're going to be able to do safety analysis so much more quickly and so much more specifically, there is always a bit of a challenge here. And I always talk about this when I talk about SWOT analysis, strengths, weaknesses, opportunities and threats. So one of the strengths of stamp-based analysis is that you find stuff And sometimes you can find things that make the hairs stand up on the back of your head and make other people in the room, oh shit, we've just found something really serious. But there's also a threat with that as well, especially when we're analysing the higher levels of a control structure where we involve management or leadership or even the regulator. We can find stuff that people might not want to be found or want to be made explicit or don't necessarily want to deal with, because it's one of those issues that they probably already know about and it's firmly on the too difficult to deal with pile. And so it just gets ignored and left and left. And so if you identify those things, which you most likely will, you've got to be prepared for the potential pushback or other issues associated with that. So one of the things I always emphasize is if you're working in an organization and you're thinking about trying STPA, before you go ahead and do it, and I know it's going to help, it will help, I'm confident of that. But if you try and apply it in an organisation that's just not ready for that level of openness and they don't have a relatively open and humble safety culture, you're probably going to run into problems. And then you end up becoming the target for the, what would you call it? The reaction to your findings. Almost like an invading virus to that organisation. They're going to try and get rid of you. So just be mindful of that. It is a strength. It's fantastic for finding stuff, but it's also fantastic for finding stuff that other people don't necessarily want to deal with. So just be careful of that double-edged sword. And if you've got any experience you want to share on that or any suggestions on how you've dealt with that, then please stick it in the chat or come up on screen and we'll talk about it. Now, in the context of CAST, I neglected to go through these tables, so I'll just quickly go through them. So as I mentioned, CAST has 3 parts to the analysis. The first part is the physical process analysis. So this is where we look at the control process itself and we explore, what are the physical components involved? Are there any controls? Are there any so-called barriers? If you're familiar with barrier analysis and bow tie analysis, what are the physical barriers involved we need to think about? What are the roles and responsibilities of those items? Are they specifically labelled as hazard mitigations, for example? And do they have any specific safety requirements or constraints? Were there any physical failures with those physical items? So this is where we cover the physical failure aspect that most other safety engineering analyses focus on. And then we've got, we identify the potential for any contributory control actions or other interactions. So for example, if we're talking about a braking system not being, a control action for braking being provided, but the braking system itself doesn't then actuate the brakes, was that a physical issue or was it a controller issue? They're the kind of things that this will highlight. And then we document, what are the reasons why, how, what's the explanation for that? Are there any things that are missing or flaws or inadequacies? What's the context, contextual factors? In this particular incident, there was some communications equipment that weren't working. There was some communications on the bridge in the fin that had been damaged by water and had to be replaced. So that's something that this part of CAST would cover. And then, of course, a summary of the role of those components in the accident, and then any questions or recommendations. Now, if you're doing an investigation, you might have a set of team members looking specifically at the physical items, while you have other team members working on the controllers and the structure itself. And these guys and girls might identify some questions and make recommendations that are actually answered in the analysis done elsewhere by other people. So, for example, when you're doing the component analysis, you might answer your own questions or seek to refine those questions and recommendations that you've made. So in terms of component analysis, we look at each of the controllers in that structure, we identify their safety-related roles and responsibilities and their safety requirements or constraints. And of course, there may be documented responsibilities, as in this case, the commanding officer had the Queen's Book of Regulations, I think it's called. Let me just jump down to here. Yeah, there we go. So the QRRN is the Queen's Regulations for the Royal Navy. And in Chapter 8, Instructions to Commanding Officers, that basically says this is what your roles and responsibilities are. And so it's important to capture those documented roles and responsibilities, but also recognise that there may be safety roles and responsibilities that haven't already been documented or allocated, and that's one of the reasons the accident occurred, because somebody, for example, didn't know or foresee that they had that responsibility logically, and that they could have done something potentially. So it allows you to look at the work as done. Work as imagined versus work as done, if you're familiar with that language. And then we look at the control and feedback ability of that particular controller. So in this accident, the officer of the watch, they were on top of the fin, and it was before dawn, so it was still dark. So of course their visual sensors, their eyeballs, aren't too good at working in the dark. So of course their eyes have not failed, their sensors have not failed, but of course the context means that they can't see very well. And then of course contributory control actions. Now you might notice when I was talking about STPA, I was talking about unsafe control actions, and here I'm highlighting contributory control actions. And the reason I'm doing that is fundamentally the control actions and whether they result in a hazard or loss are exactly the same between STPA and CAST. The only difference is when you're doing an investigation of a real system with real people, for example, they may have taken an action to stop an accident occurring, but the action that they took with hindsight post-accident was actually an unsafe thing for them to do, an unsafe action. And they didn't know that, because if they did know that pressing a button would cause an accident, for example, they probably wouldn't press it. So it's not appropriate to refer to that specific control action as an unsafe control action, because they didn't know it was going to be unsafe. And an example of that is, if you're familiar with the Chernobyl disaster, during the sequence of events in that disaster, if you've seen the TV show, it's fantastic. You've got to watch it if you've not seen it. But essentially the control room operator went to press the emergency stop button effectively, and as soon as he pressed that button, it basically blew the reactor up. The control rods were reinserted into the reactor, and given the design of the reactor, it increased the reactivity of the reactor, which basically exploded it, blew it up, and it behaved like a bomb. And you'd like to think, and I'm sure if that person was still here, they would agree that if they'd have known pressing that button would have detonated the reactor, they probably wouldn't have pressed it. But then somebody would probably say, hang on a minute, you didn't follow procedure. It's still your fault. So they're damned if they do, damned if they don't. So yeah, does that make sense? I'm hoping that's sort of coming across as, we're able to manage hindsight bias if we're very careful using this method. And of course, we've just got to manage our language as well. Okay, so the last part, the third part of the CAST analysis, is where we look at the structure itself, the control structure. Now, this list is not an exhaustive list, but these are the broad topics that are discussed in the literature, and I've added a few things that have come about from my experience myself. So we've got communication and coordination. So this could be between two controllers or across different layers in the control structure, or even different organizations. We've got structure and architecture and interactions. So you might, if you've seen the other videos, you might be aware that in this particular accident, there were difficulties with communicating between the people on the fin and those in the control room down below, because the communication system wasn't working. And so whilst the structure was in place, those interactions were disrupted because of those issues with the communication system. And then in terms of dynamics and changes evolution, this can be considered through the lens of the product, service or system itself, whether it has changed or whether the environment in which it operates has changed over time. The organisation itself, the operations or design organisation, might change. The humans involved, they may physically be changed, as in this case. I think it was at 5:30 to 6 o'clock in the morning. They had a watch change, a watch switch over. So the staff that were manning the submarine and doing the various functions, they handed over to a new watch that was coming on shift, and then they moved off. So that's a change, that's a dynamic change and evolution. And then, of course, the humans themselves, their behavior might change over time. They might become complacent. They might perceive things differently. And then, of course, there is the potential for planned and unplanned changes, and even unofficial or official changes. And then, of course, we've got the concept of a safety management system. So this is sort of you could argue from one perspective that a safety management system is essentially making the safety control structure explicit. Or you might say an SMS is a part of a broader control structure. And then, of course, the safety information system. Now, the SIS with an acronym there, it sounds really formal and really official, and sometimes it is. But sometimes it's literally just writing some notes in a logbook and storing that for future use, or even sending an email. An email is just an email, but if it contains, for example, a dose calculation for a sick patient, all of a sudden that email becomes very, very important. Then we've got the big topic everyone loves, safety culture. I'm not going into too much of that today because that's a huge topic in its own right. And then we've got economic environmental aspects as well. So external to the organisation or internal to the organisation. And then, of course, physical and non-physical aspects relating to the environment. Now, of course, again, like with CAST analysis part 1 and part 2, we've got to document, well, why was that? What are the reasons for that? What explains it? Why did it make sense for this to happen in this way? And then, of course, any context or contextual factors. In this case, this submarine was a first of class. I think it was two months or not even 2 months out of where it was when it was released to go and do these operations, these trials. And of course, everybody's new to the submarine. It's not just a new boat, it's also a new crew doing new things. People are training, they're learning things, they're identifying issues that need to be fixed. And then, of course, we've got a summary of the role of the structure in the accident, and then, of course, any questions and recommendations. And that's, in a nutshell, that's what STPA and CAST is sort of all about. So before we go further, what questions have you got? What ideas have you got? What experience would you like to share? Thomas has said, find upper level allies when you discover unwanted issues. Thomas, that is a fantastic piece of wisdom. Thanks for sharing that. Yes, of course. So if you're if you're a person that's really keen with safety and wanting to try STPA and CAST, if it's all right to have a go yourself and maybe share some of the findings with people. But if you don't have support from above, you don't want to become the person receiving incoming fire. So if you can, get upper level allies in the organisation to help you with those issues, either help you discover the issues and then help you deal with those issues once they've been found. And think about it from like I mentioned earlier on, think about what does the operations control structure look like in your context as an individual? Where do you sit in the organisation in relation to that? Because if you can find allies in the operation control structure where they are the people that are physically exposed to the hazards that you might be talking about, if you can get allies there, they can help with their real experience influence those that are more remote in the design part of the control structure, who may not have an appreciation of how serious the things are that you've identified. Darren says, the Chernobyl example set in train a culture change in nuclear. The delineation between training and education so that operators could understand what was happening when they initiated a control action and why. Absolutely, that's fantastic. I mean, are you able to share a specific example, Darren, that might sort of give people a few ideas about
that? Yeah, I mean, so full disclosure, I'm a former nuclear submarine operator. So,
okay, would you like me to bring you on screen so everyone else can see you? Are you happy for me to do that?
Of course.
There we go, everyone. You should be able to see Darren now in all of his handsomeness. So tell us about that, Darren, if you'd like to.
Yeah. So this was something that came out in my training, really, in that the emphasis was very much on educating us as to what the plant and the platform was doing, such that every control action that we undertook, we had to have this questioning attitude. So nobody on board should be pushing a button, pulling a lever, pressing a switch without intimately understanding everything that happened downstream of that and why. I'm not saying
That's
that everybody
fantastic.
does it every time, and as the example you're probably going to go into will show, it doesn't always work that way. But that's certainly the training and the sort of the education culture that's set into the engineering side of things.
Oh, that's
Probably
fantastic.
worth noting, again, in submarines, they're sort of divided in two. So the watch handover you referred to earlier is only in the forward section of the submarine. So the navigating, the warfare branch, as it were, and the weapons section hand over twice,
Yeah,
every 6 hours. The
yeah.
engineering back afters, as we refer to, tend to do a slightly different watch system, so that they're a bit more consistent. Just for information.
That's really interesting. That is really interesting. No, thank you for sharing that. Thank you. Really
No problem.
appreciate it. Fantastic. Okay, so now that we've talked about all of that, I hope that was interesting. I hope I didn't sort of bore your legs off going through the basics or the principles of it. But the reason I sort of wanted to emphasize that is just to try and embed this model in your brain. Because once you've embedded this in your everyday thinking, you'll be able to identify unsafe control actions all over the place. And it'll probably become quite shocking at first, but you'll get quicker at it, and over time you'll be able to start having guided conversations with people about how an accident might present itself, how a hazard might occur or might be released. So you can start with talking about control actions, talk about, well, why would it make sense for the controller to behave in a way that would provide those unsafe control actions? What type of feedback must they have or not have available to them to make it make sense for them to behave that way? And then how might the control process behave? Might it behave in a way that looks like it's behaving as you expect, but actually it's, there's some feedback that's misleading you? Fantastic. Okay, so I'll just quickly jump through give you a summary of the accident itself. So essentially the submarine had been on the Butech underwater range doing various things that it doesn't talk about. And after that had occurred, they needed to move towards the southeast of that location to essentially do some boat transfers, because there was quite a few people on board the submarine. As it was a new submarine, there's people testing systems and doing various things. And then, of course, because they'd been on the range doing various things, they'd got not only extra people from the range, but also from the manufacturer BAE Systems doing various things you do on a new submarine. And of course, they had to go and into this area here. This is the boat transfer grid. And essentially move into that grid, meet up with a boat from further afield from Kyle of Loch Alsh, and transfer some people, across. Now, essentially what happened is, as the boat was moving into position, there was the shift change, there were some issues with communications, there were some issues with setting up the, in the sail, not in the sail, in the fin, should I say. Where is it? There's a picture. There we go. That's it. So this is the top of the submarine. At the front, you've essentially got... I don't know if I'm using the right terminology, so please correct me. But this is like the outside bridge, if you like. This is where people stand to direct the boat. And then at the back, this is the secondary navigation position. And then you've got various sensors and things like that in between the two. Now, this, I'm sure you can see from the scale of the people, this is quite a distance. You're probably not going to be able to shout to each other, especially if it's windy. So yeah, you've got people up there. And essentially, where's the... there we go, yeah, so that's a better one. So essentially they were getting ready to move into this grid and do a boat transfer, and the officer of the watch that was in the fin, essentially controlling the movement of the submarine, they did not issue commands in time to prevent the submarine from becoming grounded on this shallow water in this area here. Now, the officer of the watch, they could have turned left or they could have turned right, but there was context to why they didn't do that. One of those contexts was that there was another vessel in proximity, and that they weren't able to communicate with that vessel because they didn't have a working radio. And of course, the people below did have working radios, but they weren't able to coordinate with each other. And the officer of the watch didn't attempt to communicate and coordinate anyway. So even if they tried, they couldn't do it, but they didn't even try because they didn't apparently think that was appropriate. And there was also some other things in the water, some fishing, where are they? There we go. There were some fishing floats in the water as well in the proximity of the submarine, which the officer of the watch identified. And that may have impacted their decision making about whether they should turn left or right. And then, of course, In fact, actually, that's a better picture there. So this is the fin, and what I've done is I've represented that fin. I'll just move this over here so you can see I've got the bridge fin at this side. Just zoom in a little bit. And then I've got the secondary navigation position on the other side. And so they're people outside the boat. You know, they're exposed to the environment. And then underneath them, there is what I've modelled a communications layer just to represent that there is a layer of technology between those levels in the hierarchy. And then below that, we've got what I've identified as the Wireless Telegraph Office, the WT office, which has some radio equipment in there. I don't have enough knowledge or experience myself as a bit of a layperson with submarine operations, and it's not clear in the investigation report if there was anybody in that physical location. I would probably guess there is, but I don't know from the investigation report. And then in the control room itself, we've got various people, various stakeholders, if you like, performing various functions in the control room. And then, of course, below that, we've got what I've labelled as a technology layer that represents how those stakeholders, how those controllers actually control and influence the movement of the submarine. So we've got the trajectory control, because that's what we're primarily concerned about, the submarine moving into an area where it becomes grounded. And of course, trajectory control as a function is in control of the submarine. And of course, that is what signifies the physical process, the submarine's trajectory. So of course, if trajectory control as a broad function is not done properly, then of course the submarine's going to end up in a difficult situation. And that could be running aground, or it could be colliding with other vessels, for example. So yeah, so are there any questions about that before I jump in and start talking about the detail of it? Do you want to stick your hand up and you can come on and ask a question or type it in the chat. Darren says the WT, the Wireless Telegraph Office, should have been closed up as the submarine would have been at a special manning state for the boat transfer. Okay, that makes sense. So would that be people in the secondary navigation position or the bridge fin doing the communication and coordination with the boat transfer? Because I think there was a mention of somebody called, the casing party. So would the casing officer be coordinating with the boat transfer team? There we go, the boat transfer team. Darren says, apologies by close up, I mean people in it. Oh, so people are in it, okay. The bridge to control room, then to the wireless telegraph office. Sorry, Darren, I'm not sure I understand what that means. Do you mean that the communication between the bridge fin goes via the wireless telegraph office to the boat transfer crew, or what do you mean by that? Sorry. John, to come up on screen, press your hand and I'll bring you up. In fact, there we go. Let's try that button there. There we go, Darren. Sorry.
My apologies. I think I've injected more confusion than I intended. The communication chain is slightly convoluted in that there is either wired or voice pipe communication between the bridge fin and the control room, and then the communication goes from the control room to the WT office for then external communications. But in the case of a boat transfer, it would normally be VHF handheld from the bridge directly to the transfer vessel.
Yes. Okay, so that would be this. Sorry, I'll zoom in a little bit on this. So stand by a second. Thanks for that, Darren. So we've got the bridge fin conceptually. That's not a controller, it's just a group I've used. We've got the officer of the watch in that location. They have, there is no VHF handheld radio. That was not present. So there was no way for them to do that communicating. So I've highlighted that interaction as a red arrow to the MV Omar, the other vessel, their trajectory control. So they weren't able to do that because they didn't have a radio. And as Darren's just highlighted, that should come from that radio, not through the bridge or the wireless telegraph office. If I've said that correctly, Darren. Yeah, fantastic. Okay. So I'll just quickly go through. In fact, no, what I'll do is I'll start at the bottom and I'll work my way up. Because if I start at the top, it'll blow your brains out. And I don't want to do that. So like I said earlier on to Michaela's question about how to abstract these things, I always practice by starting with the physical process, because that helps me to keep this model connected to the real world, to the hazards that we're concerned about. So we always start with the physical process. So we've got, ultimately it's the submarine and its movement, its trajectory. And this is logically the same for any vessel we're talking about. It doesn't have to be submarines. The only difference with submarines, I suppose, is that they have the third dimension. They go up and down, not just side to side and forward to backwards. So it is a bit different. It's a bit more like aircraft, I suppose. So what I'm saying is that in terms of controlling the submarine, this control structure above is defined in the context of trajectory control. So I'm not talking about, I'm not talking about other hazards that are not related to trajectory control. Though some of the controllers you'll see in this control structure will be related to other hazards, this structure is specifically about movement of the submarine trajectory control. So the first layer I've highlighted here is the trajectory layer, because logically no one is physically in control. No one is using their own actuators, their own hands, to affect the trajectory of the submarine. It is all done indirectly through equipment provided on the submarine and submarine systems. So I've said very broadly here, I know there's logically going to be some kind of navigation equipment. I've highlighted here this process model. So this is the in the document, in the investigation report, it talks about the ASNAPS system. I don't know what that is, it's not described. I'm assuming that it is a navigation system of some description. And by logical inference, the navigation system will capture some kind of physical model about the state of the submarine in its environment, in its particular context. So whilst it is not directly related to the control of trajectory, it certainly influences the control of trajectory, and that's why I've highlighted it. So if I was going to, if I was part of the investigation team for this particular event and I'd been asked to contribute a control structure model, I would ask for subject matter experts to help me add detail and clarify this as to whether it's relevant to this particular accident or not. Because if it's not, we don't need to include it explicitly. But given that we're trying to learn how to do STAMP and STPA and CAST, and how to do modelling, how to think about things through the lens of a control structure model, it's a good idea to include these things. There is also some I've added some other feedback here. So we've got some GPS data time from somewhere, from a GPS antenna of some description. That has an influence over the control in some shape or form, if not just the navigation, maybe the recording systems. There are some sensors, the fore and aft transducers. So they are part of what's called the echo sounder, and they provide a paper trace to tell the crew, how deep how close the bottom is to them, so to speak. And that was actually switched off. It wasn't switched on until probably 5 or 6 minutes before the grounding. Now there's a couple of reasons, context, why that echo sounding system wasn't switched on. But it's not really explored in the report in any detail. It just basically says it's the officer of the watch responsibility to turn the echo sounder on, and it just seems a little bit superficial. If it's their responsibility to do it amongst all the other many responsibilities they've got, has it not been allocated to some other individual? All of those different things they need to do. So anyway, I've included that there because it's a sensor. There is the optronics mast, and essentially that's kind of like the periscope. And then, of course, there is a radar. There's two radars in this instance. There was this particular radar, the 1009 radar, was available but not used. So they could have used that to get some sensory information and inform their mental model, their beliefs about where the submarine was in relation to obstacles. So I've included their radar surveillance equipment as a block. Excuse me. Then there's the propulsion and steering system, and again that's just a generic block. I've not gone into, in the report there's no detail about that. there's no apparent relationship between this and the causes of the accident. It was working as it's supposed to. There is a digital depth recorder, a sensor, which feeds information to the helmsman's panel, the HMI, Human Machine Interface. There is also the submarine communications equipment. Again, there's not really much discussed in that other than that it wasn't working properly, there were issues. And then, of course, there is mention of specific systems, so the platform management system, the PMS, this thing called Big Brother that's not described, I think that's some kind of recording system. So, of course, there is the Big Brother mirror process model, so what is it recording? What relevance is that to the control of the trajectory of the submarine? And then, of course, there's another system called the Little Sister, but again, there's not much discussed about that, so I can't really talk about it or comment on it. And then, of course, there is something referred to as the narrative, and that didn't really make sense to me as a layperson, so I've just put a question mark there. If I'd got some subject matter experts available, they might be able to explain what that means. There is a CR fixing log. Again, I'm not sure what CR means. And then there's the ship's log itself. And there was some mention in the report that there were some discrepancies between what was recorded and what wasn't recorded. I think there was some systems weren't available or not recording properly. Darren says CR is control room, so that's the control room fixing log. Thanks, Darren. Fantastic. So that is, given that this is a preliminary control structure, this is just, there's a technology layer. These are some of the things that are mentioned. None of them really strike me as sounding like they contributed to the accident, apart from the ship's communication equipment. And I'll just emphasise that in red, just because, is that red? It looks orange. Yeah, there we go, red. So submarines communications equipment. So if I was part of the investigation, I'd recommend let's go and have a look at this. Let's look at it in more detail. Let's look at the design aspects of this and whether there's given that this is a new submarine, are there any design organisation aspects relating to this? For example, if this thing has gone to sea with known deficiencies with the communications system, if that was the case, it doesn't say, but let's hypothesize that it did. What is the control structure interaction between the design organisation who is responsible for the design of this thing and the operations organisation? What assessments did they do? What conversations did they have? What decision? How did they justify the decision to put to sea with a system that had some deficiencies in it? Or when there were recognised deficiencies, as there were in this situation, how was that escalated through those organisations to make decisions whether to stop and replace or continue? So, and the reason I'm picking on that is just to sort of stretch your mind and think about, well, what must the control structure, what must those control loops look like to support the decision to go to sea or continue operation with those known issues? Okay, are there any questions on that before we start talking about the people as opposed to the technology in this situation? Please don't be shy. This is all about you. It's not about me. Let's hear what you want to say. Okay, fantastic. So as I said, I split the control structure into two parts, just to recognise that there are physical dimensions to this control structure, not just functional, interactions and separation. So the wireless telegraph office, I've highlighted there, it has some radios in there. And of course, those radios and the people in there are communicating with others on the submarine and perhaps off-board the submarine. There's no detail in the investigation report, so I've not included anything in there. But if let's say for argument's sake, the reason that the MV Omar, this large vessel, was in proximity to the Astute submarine, if the reason they were in proximity and potentially hindering the ability of the officer of the watch to make decisions, if we were investigating this, we might want to go and look at, well, who or what is in that wireless telegraph office? Are they related to whether this VHF handheld radio is available or not? Are the people that work in that office also the maintainers and providers of these radios? I don't know, as a silly example. Was it one of those guys or girls that's supposed to take the VHF radio up to the bridge fin Or is it entirely up to the officer of the watch to go and collect those items and make sure they're working? I don't know the details. Darren might be able to share, but we could maybe explore that if it was relevant. In terms of the control room, now this is a bit of a mess because I'm a layperson in terms of how submarines operate, and I think Darren, you can probably add some really great detail to this. But I've added these controllers because they're mentioned in the report, but I don't know how to tie them together in the context of how they influence the control of the trajectory of the submarine. So I've got the helmsman here. So this, I understand, is a petty officer. They influence the submarine through the helmsman panel and some kind of other actuators and sensors. The ones mentioned in the report are the telegraphs, and I'm conscious that the telegraphs themselves, they communicate intent and instructions and feedback between the bridge crew and the engineering section and the systems themselves. I'm not sure they're like World War II vessels. I think they're different to that in design, but the intent is there to intend to communicate a control action, and then for that action to be acknowledged, and then once the action has taken place, there is a further feedback to say, yes, we've now taken action. You've got however many revs on the propulsion system. Now the helmsman I've highlighted here as having one interaction with the petty officer of the watch, the POOW. Now I don't know the command structure or responsibility structures in here. I know there is the officer of the watch below, and they seem to be the senior person in the control room. And in this case, that role was fulfilled by the tactical and sonar officer, the TASO. There is also someone called the ship control officer of the watch, which I believe was a warrant officer level 2. There is also a navigating officer, NO, and then there was also a tactical systems officer, TSO, and a weapons engineering officer mentioned. But again, I'm not sure if they are, if they're involved in the functioning, in the function of controlling trajectory. I'm not sure that they are. I think they're separate to that. And then over on the left-hand side, we've got the plot or plotter. They are a leading seaman. And I'm presuming they're involved in the navigational plan. Let's put the navigating officer over here because that would make sense to group those together. And what I would do if we're part of the investigation, we get some navigating people together, some plotters, and we say, okay, well, what is your control structure for making decisions about the position and movement of the submarine, and how do you interact with others? I know that there is the concept of the navigational plan, so the planning activity itself, but also updates to the Admiralty charts. So in this case, they had a chart 2480, which was the inner sound central part, and then there's the chart 2498 inner sound southern part, and those charts were annotated with the grids that you saw. So these boat transfer grid, there we go. So this is an example of that chart with the boat transfer grid on it. Now when the officer of the watch, in fact actually you can see there some people right up at that's quite a distance. You wouldn't like to fall off the top of that, so they are quite high up, and the officer of the watch will be there. They should have, as mentioned earlier on, they should have a VHF handheld radio. They should have some binoculars. The primary radar information was not available to them because it wasn't used, and the secondary radar was unavailable, so of course that information is not going to be used. And they had a bridge chart, but they didn't have an appropriate chart with the annotations and things on it. So their process model of understanding where they were in the context of the boat transfer grid was inadequate. Their understanding was inadequate. So yeah, what else can I add about that? So we talked about the control room. Okay, yeah, let me talk a little bit about this. So the officer of the watch below in the control room, that role was performed by the tactical and sonar officer, the TASO, Lieutenant Commander. Now at the same time, I understand implicitly from the language in the report that the officer of the watch on the bridge who was responsible for the movement and trajectory of the boat was somebody, it's not clear in the report. It says that they are a CBO and they're a lieutenant, so they're an officer, but I don't know what CBO stands for. I don't know if Darren, if you're aware. Darren says, officer of the watch is responsible for handheld VHF. Okay, so the officer of the watch should have that handheld radio. So for whatever reason, they didn't have one. Darren says the TASO and the TSO are watch leaders, so only one on watch at any time and coordinate all control room activity. The SCOO, the ship control officer of the watch, there we go, I will remember one day, manages the operators on the ship control panel, ship systems, and the helmsman. Rank for these positions can vary. Okay, yeah, so they are, I think that's, would it be fair to put them in above the helmsman? I think that's probably more appropriate, isn't it? There we go. And Darren says cryptographic books officer. Okay, that's not a term that's mentioned in the report, and I'm just wondering. Yeah, let's stick that in. Cryptographic books officer. Okay, so yeah, I don't know the context of that. I don't know if they're. The impression I got from the report was that they were under training. So they were under training. They were supposed to be under supervision of the tactical and sonar officer. So you'll notice I've highlighted them there above the cryptographic books officer lieutenant. But I've also highlighted them down here because they were performing the role of the officer of the watch below. So there's kind of the same physical person doing two different things in the control structure. One of those is providing supervision over somebody in the bridge fin whilst also physically being in the control room. So I don't know, what sort of observations have you got about that sort of realisation? We've got the officer of the watch below who's a TASO that's also overseeing the officer of the watch on the bridge fin. Do you have any thoughts about that? Are there any other things about it? Darren says there are numerous titles for warfare officer. CBO tends to be a junior officer. Thanks for that, Darren. That's fantastic. That helps me understand a lot. But yeah, so if we were talking about, where is it? If we were doing a cast analysis and we were thinking about things through the lens of structure, we've got dynamics and changes evolution where we had a watch handover, changeover, and then also they're setting up the bridge fin to do the navigation. You've got a young relative, well, I don't know, can't comment on the name, but let's say the experience of that particular officer, the CBO officer, if they're relatively new to it, they're under training, under supervision, then what should the control structure look like to support that, those responsibilities, making sure they're enacted and making sure the person doing that has the support they need. If they don't have a radio, should somebody be looking after them and monitoring them and making sure they've got the radio? If it's supposed to be this person, the TASO, and they're the officer of the watch below, they can't disappear up the fin because they're the officer of the watch below. So how does this person make sure that this person up here has the right equipment and has all the right feedback and everything else for them to be able to do the role? And if their decision making is, not adequate because of their experience or whatever reason, why is the TASO not able to step in and deal with that? Who else should be involved in that? Okay, fantastic. So we've talked about all of those. We've talked about the main parts of the control structure. What I'll do now is I'm just going to talk about some of the higher level parts of the control structure because they're mentioned in the report. So up here at the top, I've just mentioned some of these document related, procedural related controllers. Now, they're not documents and procedures and training is not strictly a controller, because they can't make decisions themselves. They don't have the ability to provide control actions. They rely upon people, either individuals that need the procedures and read them and get them in their heads so that they can take actions and make decisions, or they are provided by training organisations. So somebody who is new to a role and they need to know what the COC orders are, of course they need to be provided those C orders, and there should, in theory, be some kind of feedback loop to make sure that they are aware and competent with the content of those orders. And that goes with the standing orders, the emergency operational procedures, the use of the main radar in this case, night orders, procedures for planning, executing, for navigation. And of course, in the aftermath of the grounding, there were some phase 1 damage checks that were done that were not ordered. So how those damage checks are done and whether it's appropriate for this type of event. Now, interestingly, there was mention that the emergency operational procedures, the EOP, were used. And the grounding EOP was not immediately obvious to the crew because it was buried inside the collision EOP. Now, for me, that's interesting. I've not modelled it here because I don't have enough information and it'd just be blind speculation. But there's a question there over the organisation that creates those procedures. You know, are they standard procedures from the boat manufacturer, BAE Systems in this case, or are they a combination of Royal Navy procedures brought together and then put into the boat themselves? And why did it make sense for the people involved in that to keep the grounding EOP content inside the content of the collision EOP? Was it that that was just standard practice and that's how it's evolved over many submarines over many years? Or was there a mistake in the process of creating those procedures and assuring that they were correct and it was missed? And if so, you know, that might make a particular recommendation for further investigation and maybe a recommendation to potentially fix that if that's an issue. So that's all documents and things like that. In terms of the Royal Navy command structure then, so I'll just move this out of the way over there. Of course, on the boat themselves, there is the commanding officer, and they are, you know, they're the pinnacle of the control structure, the operations control structure on the submarine. They're ultimately the responsible and accountable for the safe conduct of the submarine and making sure that it's, you know, does what it needs to do. And of course, on this occasion, they were not available in the control room or on the bridge fin because there was a shift handover and they'd actually gone to have a shower and freshen themselves up and get them ready for the morning's operations. So they weren't actually available on the bridge at the time. And the commanding officer sort of came, where is it? Came for quite a lot of criticism. Where is it? Maybe it's not that bit. It's a bit earlier. Trying to remember where it is. Oh, there we go. Look, here we go. So the preparations for and conduct of the watch by the officer of the watch fell short of the standards required to maintain submarine safety. Okay, I mean that's a fair comment, is it? If this person was under training and not had the appropriate oversight and support to be able to perform the critical role that they were performing, is it really appropriate to say that they fell short of standards? I'm not sure. The planning for the boat transfer was insufficient to ensure safe completion and lacked appropriate command oversight. So again, what do we mean by command oversight? Who are the roles, who are the people and who are the roles in the control structure that should be involved in that? Why were they not present or equipped to be able to do that? Who makes those decisions? You know, is it the commanding officer? Is it other people? The boat transfer was planned to be conducted at patrol routine and not river routine. So this is an interesting one because this talks about the state of the submarine, the way it's set up, the way the crew on board are operating, the level of vigilance that they have. So in river routine, this is a higher sort of vigilance level, you might say. And at patrol routine, it's slightly less. So there's a question there over, well, why wasn't the control structure evolved into the river routine when it was at the patrol routine? Who makes the decision to do that? What is the criteria to make that change in state? And what are the circumstances around that? That's not established in the report. So let's have, what else about here? So there was river routine would have ensured that echo sounder trace was running and manned, and would have also resulted in conscious decision on whether to operate the 1009 radar. River routine would also required the officer of the watch below to have been a seaman officer vice the logistics officer. So I wasn't sure what that meant. That didn't quite make sense. Is that the logistics officer was performing that role at the time? And if so, is that appropriate? I don't know. Were they trained and qualified for that? If not, why was it? Why were they in that situation if they weren't? What was the control structure around them? Why was the control structure inadequate? That fact that the boat was not in river routine is highly unusual in the opinion of the service inquiry team. There would not appear to be any legitimate reason for what is standard practice in other submarines not to have adopted on this occasion. Okay, so if in other submarines that's how they do it, why was it different in this circumstance? What was it about the control structure or the behaviour of the controllers in that structure that meant that they didn't go to river routine? It's not explained. Okay, we were talking about the commanding officer, and there's a part where they particularly criticise them. There's a part about the handheld radios. There was no handheld radio on the bridge which prevented the officer of the watch from communicating with the MV Omar vessel at a critical time. However, VHF was available in the control room and wireless telegraph office throughout, but never considered. Again, it's some of the things that this report writes, the way that they write it, it's quite sharp and accusatory. It's kind of like, well, it's these people's problems, it's their fault. But it doesn't actually go on to talk about, well, why did it make sense for them to behave the way that they did? What was the context around them? Why was of course they're not doing a cast analysis, but the question is, well, they're in a control structure of some description. Why did it make sense for them to behave the way that they did? It doesn't sort of go that extra step. And I think it goes back to what we were saying at the beginning, that there's a lot of things mentioned in here that hint at broader systemic or cultural issues that are not discussed or addressed at all. They sort of hint at it and then stop short. And if you were to do a cast analysis of this, you'd be able to go so much further. But again, I'm not sure the culture of that organisation, with the way this report was written at the time 15 years ago, would really be supportive of that, detailed investigation, if you like. It is the opinion of the panel that whilst there were a number of individual and collective failings within the navigation and command team aboard the submarine, and that these were compounded by a number of contributory factors, the failings observed are not indicative of wider failings within the submarine service as a whole. It is the view of the panel that this grounding was caused by failures specific to HMS Astute. And if you saw my other video, I've essentially said, I'm not sure I agree with that. I think there are, how can I put it? Whenever you have a near miss or an accident, it is direct evidence that the control structure model is inadequate in some shape or form. And the question then becomes, well, who is responsible for the control structure on board a submarine? Well, it's a combination of the commanding officer and the people involved and how they organise and do the tasks that they do. But also it has to come from the Royal Navy. It has to come from the higher levels in the control structure model. So how do they define how the control structure in the submarine is defined and how people operate and how people are trained, and whether it's acceptable to have people that have minimal training put in positions that are very, very important for the safety of the submarine. So I think that's a bit of a cop-out, my personal opinion. And if they were to use cast, they'd be able to go so much further. But again, I'm not sure that they would be too happy with having the light shone on themselves. And with that said, I'll just quickly jump over to the higher levels over here. So I started talking about the commanding officer. So they were given permission by the Commander Task Force 311. So they are in charge of the attack submarines at Northwood HQ, the Royal Navy Commander Operations ComOps. And they provide formal approval for the float off. So after the 18 or so hours that they were stuck on the ground, when they were grounded, they were given permission to float off after they'd received advice from the MOD Salvage and Marine Operations representatives, the SALMO, who received information about the submarine from the divers. So they sent some divers in the water, and it was fortunate that the water conditions were such, and the submarine and the terrain and everything that they were stuck in, they could see the state of the submarine and that it wasn't damaged too badly, so they could actually refloat the submarine. So that's sort of just giving you an example of a control loop providing a sensor. In this case is the divers. They're looking at the physical state of the submarine and then passing that information to some specialists, salvage representatives, and they provided that feedback to the Commander Task Force, who was empowered to make the decision for the submarine to be refloated and floated off. Now, I'm just thinking, what else can I add about that? There's not really that much talked about the commanding officer in the report. It's really quite strange. That's why that is just sort of stuck as it is, because it's not clear to me how the commanding officer coordinates or talks with these other elements. That if there's a break in that structure, then that's really, really not right. So Seraj Kinjaki, hi Seraj, thank you for coming along. Hi Simon, I have to jump off now. Thank you a million for this. I'll reach out to you soon. I have a lot to discuss with you. Fantastic. No worries, send me a message and we can set up a call. Mark, Simon, thank you for an interesting evening. Apologies, must leave for a family commitment. That's fine, Mark. It's great to see you. Happy to talk and answer any of the questions you've got. Take care. So yeah, I think that's pretty much all I've got to say about the control structure at this moment in time. What other questions do you have? This is open to you now. What would you like to talk about? If you want to stick your hand up and let me know, I'll bring you on screen. We've got Andy and Darren. It's just us two guys. So what would you like to talk about?
So
there we go.
What you said about the planning, because somebody's obviously planned to go into the wrong what you call it mode there, wasn't it? River. I can't remember what you called it.
Patrol routine and river routine.
Yeah. So it sounds like something incredibly wrong there, doesn't it? Because obviously I assume that Karl Lochalsh, I assume the Navy says as soon as you come into a certain area, you're in river routine. But it sounds like the commanding officer planned for something different. It just doesn't stack up to me.
Yeah, there are a lot of questions, and for me as a relative layperson, submarine operations, I don't know whether they're genuine questions and concerns or whether there's an obvious reason to somebody who's an experienced person. There's an obvious reason why it made sense to do that. So it's kind of difficult to comment. But
I can maybe shed a bit of light on that, Simon. I mean, you mentioned about the control structure stemming from command, and they do. So the overall understanding of how these operations should be conducted is well documented. Hence the need for things like river routine patrol. There's numerous of these. My interpretation of it, and I was actually at sea in another submarine when this happened, and the XO of this submarine actually joined ours later.
Right.
So we got some insights into this. There's an element, I think, of complacency. So they've done about 6 or 8 boat transfers in the vicinity in preceding days. And I think they just got overconfident, really. They got to the point where they think, this is a piece of cake. We know what we're doing. We don't need to go into patrol routine or river routine for this. And that's when it gets you, isn't it? That's when you slip outside of your control structure because you think you know what you're doing, and then there's that kind of stacking up of errors. I think in terms of the people involved, the officer of the watch, they have to be qualified to take on those positions. They have to be platform endorsed by the commanding officer. So whilst they're a junior rank, they are experienced. I was surprised, however, to learn that the officer of the watch below at one point was the logistics officer, because that's very unusual. They can be ship control officers of the watch, but I've very rarely heard of them taking on the navigational role because they're not navigators.
Okay,
it feels like a cultural slip here on board that particular submarine, where they just decided that they didn't need to follow the control structure.
Okay, that's interesting. Before we continue, what you've just described, do you want me to cut that out of the video? Because I intend to put most of this video onto YouTube, but I don't want to go sharing anything that might be sensitive.
I don't think I've breached any classification there.
No, of course not. I didn't think you did. I just it's just the report is not as explicit as that, and I did wonder why.
I think back to what I said now.
Yeah. Well, just the logistics officer and the general level of complacency.
That's just my interpretation of it from reading it. I've no issue with that being shared. It's just one man's view. It's not accusatory. Just the narrative would appear to suggest that this is an operation that had become familiar, and therefore it would lead one to conclude that maybe there's been some lapses of judgment or lapses of consideration of those procedures. But I wasn't there, so.
Well, I just want to emphasize that, because it's I get the impression from the tone of the report, and it is 15 years ago now, so maybe things have evolved over time. But the tone of the report sort of hints, or there is implications of certain behaviours and certain actions, but it doesn't then go ahead and explicitly state them and then go ahead, this is the situation, so what? This is why it's important. This is what the recommendation should be. It's very quite superficial. I wasn't too keen with it, but like I just showed you on the, let me just make my screen bigger again. There we go. So just to sort of emphasize, in the CAST analysis, the structure analysis, this is where we'd think about human behavior. Is complacency and perception creeping in there? Was that an aspect that we want to consider? And of course, this investigation report wasn't done using CAST, so they're not going to dig into that in any detail. And what I'm saying here is, this process allows you to go and explicitly consider those things, but be mindful about how that might be perceived and how people might react. But that's a different problem to solve. That's not a, you shouldn't allow those things to stop you in investigating or asking the questions, but just be mindful that how you present that, to the end client, so to speak, that they don't go crazy and get upset about it and throw the toys out the pram when the spotlight is shone on them. But yeah, just want to quickly put the map up. So I don't know if you're familiar with the area, Andy, but this is the part of the world we're talking about, and the submarine. So this is it was around this area here that it ran aground, and this is the Isle of Skye bridge. The lighthouse is just there. In fact, if I just let's see if it goes on. There we go. Look at that, amazing. Yeah, so down there somewhere was where it happened. And then underneath this bridge to the east over there, that's where the Kyle of Lochalsh Kinetic Butec dock is, where the boats moved from. I'll just zoom out so you can see. Yeah, so there's the jetties and everything. There's the helipad. So yeah, that's that. So I'm just thinking, what else can I spout about this? I suppose one of the topics I could talk about, and I sort of hinted at it in my email, is the other accidents that I've been looking at as well. So there's this one here, which is the this occurred in November 2018, so 7 years ago yesterday. Is that 5, 6, 7 years? So this was the Stena Superfast ferry and a submerged periscope depth submarine in the Northern Channel. So they were floating along, and off the bridge of the Stena, you see this disturbance in the water, and that's a periscope. There's a massive submarine underneath that, and let's have a look. That's the Stena Line ferry. It's not a small one. It's pretty substantial, and this was the location between Northern Ireland and Scotland. So you've got this area here, which is also a submarine training area. And then this is the path. So the red line is the path of the ferry. The dotted line is the the path plan of the ferry. So that's where it should have been going. And so it was off the path just a bit. And then there's the near miss with the submarine, which is the estimated track of the submarine. So the ferry, if the ferry had not detected the submarine and turned away, there's a very real possibility there would have been a collision, and of course that would have been very serious with a big vessel such as a ferry. And this is the view from the side window on the bridge of the ferry, so you can see how close they were. They were very close. And this is the bridge of the ferry with all the various navigation equipment on board. Let's have a think. So yeah, and that's a better picture. So the ferry essentially detected the submarine. One of the watch crew doing the watch, they saw it. They saw the periscope, and then within 30 seconds, then they were changing track. So that 30 seconds was really critical from them actually colliding with the submarine. and the closest point of approach was approximately 250 yards. So that's really close for such a big vessel. And then there was another incident involving a trawler. So this was the Karen stern trawler and a dived submarine. And essentially what happened is the submarine came out from the submarine base on the surface passage, then they dived. That's what the red arrows are. And then the collision occurred just between the Isle of Man and Ireland. And essentially where is it? There we go. So essentially the submarine caught the rigging of the trawler over the back of the boat, and it started to pull the boat. Unfortunately, the rigging was ripped off of the boat. Otherwise, there's a strong possibility that this could have been far, far worse. And there we go. How can I rotate that? Essentially, the submarine caught the trawling gear and nearly pulled the ferry underneath. That would have been really serious, and they were very lucky to get away with it. Now, interestingly, there was another accident that occurred in 1990. So this was between the HMS Trenchant and the Antares. Similar sort of circumstances. Essentially, the submarine caught it and pulled it underwater, and they didn't realise that that's what happened. So there's a better picture of the rigging on the back of the net, and on the back of the trawler. The submarine caught that and essentially pulled it along and then underwater, and that essentially would have been a repeat. This was in 1990. The other one was in 2015. So it could have been a repeat. And so there are various procedures now in place called fishing vessel avoidance, and that describes how the submarine should operate when they detect fishing vessels. Now, in the case of this 2015 event with the Karen, I understand that the submarine crew had not identified it and classified it as a trawler. It was just a commercial vessel. And so when we think about the mental model, the beliefs of the operators of the submarine, if they believe incorrectly that it's not a trawler, they're not obviously going to deconflict away from the potential for the trawler equipment under the surface. And so what I'm saying is, from a control structure model perspective, the control structure model on a operational submarine will be broadly the same. I imagine that it's not really changed that much since the 1990 incident. And so I'm not saying it's static, but it's broadly well understood by the crew and how they operate. But the challenges come from things like, those roles, those controllers in the structure, they are fulfilled by specific individuals. And they all have different skill sets, they all have different personalities. And of course, their training program and the way that they're selected and trained has to equip them so that they can perform safely and fulfill the responsibilities in that control structure. But if the selection and training process doesn't do that, there are questions over what that selection and training process control structure is. And of course, that's not a topic that's touched on in the Astute investigation, and I've not dug into these three previous investigations to find out any specific detail. But it would be something that if I was the investigator, I would recommend going and looking into. And interestingly enough, this the ferry near miss, this one of the recommendations from the Maritime Accident Investigation Branch is for the Royal Navy to deliver an independent review of the actions taken following this and previous similar events to provide assurance that such actions have been effective in reducing the risk of collision between dived Royal Navy submarines and surface vessels to as low as reasonably practicable. Now, I don't know if that recommendation has actually been fulfilled and whether there is a publicly available report from the Royal Navy, but some of the tone of these MAIB reports seems to imply that the Royal Navy was not as perhaps responsive and supportive to these investigations as you might expect. But again, it is they are submarines. They are, the operations are classified, the way they operate, everything else is necessarily hush hush. So again, maybe that is the reason why the tone is the way it is. But yeah, that's just generally everything really that I wanted to sort of talk about. Were there any other things that you'd like to talk about? Are there any other hot topics that you'd like to discuss. And perhaps, if you want, we could talk about something completely different. Do you have a particular issue that you've got in the work that you're doing that you want to discuss? And if so, I'm quite happy to cut the recording and we can talk about that. Otherwise, I'm happy to call it an evening.
Nothing from me, Simon. It's really interesting. Thanks. Are you going to continue to develop the control structure and stuff that you presented, or do you think that's reached as much refinement as you can possibly get to? I guess, given the information available.
Yeah, absolutely. So for that particular accident, the astute grounding and the available information and report, I can't really refine it any further and make it look nice and pretty. I'd argue there's a lot of holes in it that need to be filled in, but obviously I'm not part of the investigation and I don't have access to SMEs to be able to do that. So if I had access to people, then I would like to refine it further. But for me, for the case study, I think that's about as much as I can do.
Yeah, no, it's really useful. Thanks. As you say, it sort of points to things that need further investigation.
Yeah,
really useful. Thanks for that.
No, you're welcome. It's great to see you. Thank you. So yeah, Darren, what would you like to say?
Really interesting. Thank you very much for that. If you do find you have a need for some submarine SMEs, do give me a shout.
Yeah, sure. Thank you. No, I really appreciate that. Thanks, Darren.
Populate the model.
Sure. And then likewise, if you guys need help and support, I'm available. I have some availability in 2026 and also the end of 2025. And then, of course, in terms of training, so I am on the cusp of sending an email out and inviting people to sign up to my now formal Stamp Foundation training. So I've been working on this for quite a long time. It's gone through various iterations and I've worked with various people and organisations to get to this point where I feel I'm able to now provide a more formal supportive Stamp Foundation training, which essentially equips you, or if you've got team members, your project members that need this kind of support. The foundation training is intended to create people who understand the basics of what Stamp, STPA and CAST is all about and equips them with the ability to provide a meaningful contribution to a project that they're working on. So they get the basic standard. And then, of course, I've got some more advanced training for practitioners, so analysts, modelers, leaders, and recorders, so to speak. Because this is a team sport. It's not just one person doing the analysis all in isolation. You do need people who represent those layers and controllers in the control structure, as well as somebody who has the skills to facilitate an STPA or a CAST analysis, and of course play as referee. Because like I said, when you're doing an STPA analysis of a system, there's always a possibility that you'll have people who are very experienced and are like, oh, well, we already know about this. Why are we talking about stuff that we already know about? We know that failure is not a problem. And when you start talking about dangerous successes and their mind is very much about, well, we just need to worry about failures, don't we? It's not going to fail. It's triple redundant. It's amazing. And you start saying, well, I'm not too worried about the failures. It's the dangerous successes that we should also be thinking about. Sometimes that can be quite a difficult topic to address. So if you need somebody to help with that, I can help you with that and likewise train you to be able to deal with those kind of situations. But anyway, that's fantastic. Thank you so much for your attention. Thank you for coming along. It's really great to have those conversations and share that experience. And like I said, if you do have any questions, please don't hesitate to reach out. And I'll see you on the next session. Take care. Have a good night.